Okay, the session is being recorded. This is for your information. So I'll start with today's session. That is, I have given the name of the topic for today's thing is wireless ad hoc and sensor network basics. So mainly we will see some of the hardware related things today. So this is the first slide for today, and what we are finding is whenever we are saying that it's a wireless ad hoc sensor node, what is actually there inside those wireless ad hoc sensor node? Now, if you are forming a sensor network by using cellular phones or mobile phones, then each of the cellular or mobile phones become a node. Okay, not necessary that we always have to use mobile phone nodes, but we can design our own sensor nodes for some kind of sensing purpose, and we can use that sensor node for local or global sensing, measurement, and data tracking. So what is there inside those sensor nodes? Now, what all things I have shown here in the slide, you can see that all these things can be found in a mobile phone also. So if we are talking about a cellular network, in that case, each of the mobile phone becomes a node. And if we are designing our, suppose we want to measure temperature within a certain area. Okay, in that case, we will be designing this kind of node, and what other things, what other hardware the node will be comprising, that is shown here. First thing, in every node there will be a processor. And a very big problem I'm finding with students that they don't call processor. If I say what processor you're using, you say Arduino. So Arduino is not a processor. Arduino is a brand name, and in Arduino board is also using some kind of processor that you have to find out exactly what processor Arduino board is using. So just see what is the processor, what is the internal configuration in that, how much is the memory space allocated, or depending on the work, depending on the amount of data we want to latch, we are supposed to design the storage or memory for that. So first thing in any node, what I would like to draw your attention into is the processor. Now if the processor is very highly capable, then we can latch a lot of data, we can store a lot of data. If processor is very fast, then the processing done by the sensor node will be very fast. Most of the time sensor node does not do processing in case of wireless sensor network, but yes, in case of WAN-net, MAN-net, they do a lot of processing also. So for wireless sensor network, which is the third type, so yesterday we have seen there are four types of ad hoc network. First one was MAN-net, second one was WAN-net, third thing was wireless sensor network, and fourth thing was WMN. Okay, so in case of MAN-net and WAN-net, onboard processing is done, but in case of wireless sensor network, only sensing is done. So just see what a node comprises. So this can be a standard question in your exam. So basic components of wireless ad hoc sensor nodes. So you have to start from the processor. What are the things that define a processor? Its speed. What is the RAM, ROM if required? Then what is the bit of register? It can be 8-bit, 16-bit, 32-bit, whatever. So those are the things that is deciding the capability of a processor. How much is the storage? What is the memory in the processor that is added? So apart from the processor, there is sensors. So what all thing you want to sense by using that sensor node? Not necessary that it is one sensor on one board. Generally, it is multi-sensor board. So in industry area, we can sense, suppose temperature, pressure, some kind of gas, presence of some 3-4 different kind of gases and their concentration in the air. Then if possible, there is methane, then there is heat, then there is airflow, all those some 7, 8, 10 different sensing parameters, so different parameters we can sense by one sensor board. Okay, so that is called as multi-sensor board. A lot of different things we are sensing at the same time. And after sensing is a analog data, so a lot of sensors are there. Now this data is converted to digital form, and that digitized data is entering the processor. So this is mainly the sensing and processing part. And apart from that, there is a transceiver. So whenever there is sensing done, processing done, then all the sensors nodes wants to send the data to the base station or sync node. So for that, transceiver is there. So transceiver is nothing but the transmission and reception module. So there are different types of transmission. It can be RF, it can be Zigbee, it can be LoRa, it can be Bluetooth, okay, it can be IR. So there are different kinds of transmission reception module which are there. Their bit rate is different, their bandwidth will be different, their distance of communication will be different likewise. All these circuits require energy, and there is an energy processing and distribution unit. Generally, all the sensor nodes are standalone nodes. That's why they'll be connected to battery. Now, if somebody says that I want a self-sufficient sensor node, in that case, you can connect solar panel with that. So whatever energy solar panel is procuring, that will be channelized to all these internal circuits. So sensor, ADC, processor, storage, transceiver, energy processing unit, power generator, all are the part of a very standard wireless ad hoc sensor node. Above these two things, blue things, these two blocks are called as spatial blocks. They are mobilizer and location finding system. So for location finding system, you can use GPS kind of a thing. So every sensor would know exactly its own location, and every sensor would also know by collaborating with each other that which are the sensor nodes that are near around it. Okay, so location finding system is a special unit. So some sensor nodes might be having location finding system in it. Okay, what is meant by mobilizer? I told you yesterday that if we are putting some sensor node on sea, at the surface of sea, and either sensor nodes can be going with the tide. So as tide goes in and out, sensor nodes will be moved accordingly. Otherwise, there is a flagella kind of a thing. So it is very small tentacle kind of a thing. So with that flagella or with small wheels kept on the sensor nodes, the sensor nodes can move on its own. Okay, so mobilizer is nothing but sometime it is wheel, sometime it can be wing. So some sensor nodes we are supposed we want them to fly. Okay, in that case, the wing can be the mobilizer. So mobilizer is something which takes the sensor node from one place to the other. So sensor, ADC, processor, storage, transceiver, and energy. These are the basic units of any sensor node. Whereas location finding system, GPS, mobilizer, either wheel or wing or flagella, they are very special kind of features added to the sensor node. So these are the blocks. If it is asked for 8 or 10 marks, you have to draw this block diagram neatly, and you have to explain what is the job of each block. So all the blocks you can divide into two parts. One is basic blocks. In that case, sensor, ADC, processor, storage, transceiver, and energy. That will be the standard blocks. And special blocks can be location finding system and mobilizer. Little bit of theory I have given here. Actually, this is a part of chapter number 4. But without the hardware understanding, I cannot explain a lot of things in chapter 1, 2, and 3. So that's why I have brought this hardware concept in the first chapter itself or in the preliminary itself. Okay, so within whatever diagram I had shown here, a little bit of theory I am giving for that. So special components in sensor nodes. Inside a sensor node, now the sensor nodes are very small actually. It might look like a small matchbox or even smaller than that. So images are there in the next slide, we will see. So there are mainly 7 systems as we are finding here in this slide. So first one is, you can say first one should be power generator. Okay, so here I am saying that first one is location finding, but yes, first one can be the power generator. Then it can be mobilizer. Mobilizer can be wheels, wings, flagella. So flagella is something like that helps you move inside the water. Okay, if it's on road or if it's on terrain, it can be wheel. If we want the sensor network to fly or sensors to fly, we can put wings. But whenever we are flapping the wings, sensors are flapping the wings, and then energy requirement will be more. Okay, so whatever battery you are supplying, that might not sustain the flight of the sensor node for a longer time. Okay, so sensor network, whenever we are deploying, not necessarily that sensor network will deploy for 6 months or 8 months. It happens sometimes that you are deploying the sensor network, it will work for 2 hours, battery will be exhausted, and all nodes will die. So that is also possible. So for very critical application, that is the case, that sensor nodes are working for 1 or 2 hours, sending the data back to the base station or sync node, and sensor nodes are dying and nodes are wasted. Okay. So what are the blocks? Blocks are mainly power generation. So power generation, if battery is there, then no need for generation, it is already generated. But if somebody says I want to extract, so that is called power scavenging circuit. If I want to extract power from solar or maybe tidal or maybe from some other source of energy, then power generator block is there as a part of the sensor node. Then there is location finding system, GPS and all those things are there. Then there is mobilizer. I explained you what is mobilizer. Mobilizer makes the sensor node to move from one place to other. Small memory or storage unit associated with the processing unit helps in collaborative sensing and signal processing. Then there is transceiver unit. So this below 4, 5, 6, 7, these are essential units. 1 and 3 are very special units. And power generator is also an essential unit. Transceiver unit, it communicates with the base station and all. Power scavenging units such as solar cell connected with system power unit. Location finding system, it is actually sensing and data routing requires location info. So exactly where does the sensor node deployed? What is the location of the sensor? Depending on that, it will decide the path for routing and other things. So there is a small paragraph given below. It says that all of the subunits. So which are the subunits? The previous slide, all these. So 1, 2, 3, 4, 5, 6, 7. So there are 7 subunits we can see here. If asked in the exam, you have to explain all the 7 subunits. So all the subunits may need to fit into a matchbox sized module. So the circuit should be very small. The required size may be smaller than even a cubic centimeter. Okay, even smaller than a cubic centimeter it should be, which is light enough to remain suspended in the air. So if it is a sensor network designed for aerial application, then the sensors has to be very light. Okay, apart from size, there are some other constraint for sensor nodes. Actually, sensor ad hoc nodes are always working in some kind of a very limited constraint kind of a environment. Bandwidth is constant, energy is constant. These nodes must consume extremely low power, operate in high volumetric densities, have very low production cost. They should be autonomous, they should operate unattended, and they be adaptive to the any kind of environment. So if you are just deploying the sensor node in some forest or maybe some volcanic area or some terrain, every day you cannot go and attend the sensor nodes. Okay, just you have to throw it and sit quiet. Okay, so in that case, let it be rain, let it be very hot sunshine, and let it be any kind of physical environmental problem, the sensor node should be able to work very properly. So that is why it is called operate unattended, and in a very harsh environment also they should be able to work, they should be able to sense the data and send the data back to the base station. So it's a very critical kind of application. But yes, electronics, the advancement in the electronics has helped us, and we can design a very good sensor network and with the sensor nodes. It's a very important slide. You can see nodes of wireless ad hoc networks. Just see the first was UC Berkeley. So UC Berkeley is University of California, Berkeley. They had designed quartz or dust. So this is a very small coin. This is kept just to show you what is the size of this sensor node. So this is one sensor node. This sensor node is having all this processor and battery and power and energy generating circuit. Then they might be having the GPS kind of a location finding system. Then they might be having mobilizer, sensor, and memory and all those things. So this is very primitive kind of a thing. Name is dust, and it is very light. And then UCLA, University of California, Los Angeles, they have designed WINS, WINS. So all these things are having short form. W obviously stands for wireless. Okay, Rockwell, they have produced WINS. They are also very small thing. UC Berkeley, they have produced a further version of quartz dust. Okay, this is smart dust. You can just check how small it is. Okay, it is even lesser than a centimeter also. And JPL, they have designed sensor waves. So this is also having a cover onto it. So this is actually the same sensor wave here. Okay, so these are some of the, and this is another thing. This is called Mica Mote, MICA-MOTE. So this we will be studying in detail in chapter number 4. So Mica Mote is very widely used. Berkeley Mica Mote is very widely used small sensor node, which is used for wireless sensor network for, yes, temperature, pressure, and air velocity and other things tracking. And this thing is having GPS also inside it. So this is actually the first thing that I wanted to tell you. That is, what are the different components inside a sensor node, and what are the special components inside a sensor node, what are the features. So this paragraph is very important. If I ask you what are the features of the sensor nodes, then you have to say, apart from this, so first thing you have to say, they may be very small in size, they have to be lightweight, and they are always working in a constant environment, and they consume very less power, operate in high volumetric densities. That means a lot of sensor nodes are put together, and each sensor node is very close by to each other. They have low production cost. They can be dispensable. Dispensable means you can just throw it, it does its job, and then it is lost. Okay, you are not trying to retrieve it. They can be autonomous, they can operate unattended, and they can be adaptive to the environment. So special 9 or 10 characteristics have been put into this. So try to remember all this. So this is a very important questions to understand, and for exam also this is very important. So these are, this below paragraph is the feature of all the sensor nodes. And then this slide is actually giving you all the different types of sensor nodes which are defined. So they are very primitive actually. Present day, all the sensor nodes are still further smaller and of higher capabilities. This is an example actually. This is not, I can say it is not directly attached to the syllabus as such, but whatever thing we have seen previously. Okay, so previously I had shown you one node, and in this case I am showing you a whole network. Okay, now what is this thing? This is called example. This is a airborne wireless network, and on this aeroplane there are a lot of sensors put just to track the performance of the aeroplane. So what are the different sensors put on that? So on wings we are putting smart sensor, temperature and humidity sensor. See, the aeroplane goes almost 10 to 11 kilometers above the ground, and temperature there at certain times can be minus 50 degree, minus 60 degree, and such very less temperature makes plastic brittle. Okay, so plastic can break. So then also this sensor should sense it should do its job at that very low temperature or maybe very high temperature. Sometimes there will be rain, sometimes there will be heavy airflow, but this vibration sensor, strength sensor, piezoelectric, RFID, temperature sensor, they all are put inside and above the body of the aeroplane, and they should behave very properly, and they should work in a uninterrupted fashion. So this is an example of a sensor network starting from the aeroplane body. Then all these different kinds of temperature data, vibration data, strain data, piezoelectric means pressure data, all these data are collected in different access points. Okay, so I will be sharing these lectures with you. You can check here. So these are access points. Just be careful with the thing I am pointing. Okay, the pointer, just see. So these are access points. So these access points are inside the aeroplane only. So these are kind of data sync point, or these are kind of local base station. So many data is being captured at different access points which are on the body of the aeroplane or in the cockpit. Then this access points are sending the data to the beyond AWSN. So they are sending the data to the different gateway. Okay, gateway is something through which the local data goes global. Okay, so inside the college we are doing all the computing and all the other things. So whenever we want to send the data to outside GIT, it happens through the gateway. Okay. So if this aeroplane tries to communicate to the base station, so base station is there, you can check this is on aeroplane body, then at cockpit also within the aeroplane. So this is the intermediate stage, and this aeroplane wants to talk to the base station. So base station can be on earth, ground air traffic control, ATC it is called, or it can be satellite. So sometimes what happened is aeroplanes are tracked by a satellite itself. Okay, so that's why I have said base stations. So base station can be on ground, base station can be a satellite, all those things. So this aeroplane wants to talk to the satellite or wants to exchange data through the satellite, or the satellite wants to get the data of this aeroplane. Then first the data is sensed, given to the access point. From access points the data goes to the cockpit, that is at different gateways and all, and through cockpit, so this is the bus. Okay, and then it goes in wireless fashion, different portable devices. So it can be mobile, it can be laptop, then or cockpit displays. In cockpit also the pilot should see what are the different data on air pressure, maybe fuel, maybe temperature of the aeroplane. Okay, and there are different control systems. So whenever there is control system, there should be some sensed parameter. Okay, whether all the doors are closed properly or not, whether the air pressure inside the aeroplane is made proper or not, whether oxygen is there or not, anybody is having trouble with oxygen, or maybe temperature, all those things. So these are actually the it is called that in between cockpit and in between aeroplane, these are the things which are getting continuous data from the sensor network, which is there here in the left side. And then through cockpit, through the communication module of the aeroplane, the base station, ground station, or satellites, they are connected. So this is from local, that is from one aeroplane body, to the universal kind of a data exchange platform. So this you can explain in your own word, and this you can explain in your own language. So this is a application of a sensor network or ad hoc network, which is called as airborne wireless network. Such many things are there. Somebody can design a wireless sensor network for agricultural field. So on soil you can put irrigate for irrigation purpose, you can put soil moisturizer sensor, you can put the temperature sensor, humidity sensor, you can put some kind of chemical sensor. So there are a lot of chemicals on soil that might help you, or sometimes it might go against to some kind of specific crop. Okay, so you can sense all those chemical sensors. So some 8, 10, 15 sensors can be there together on the soil, and all those data are captured in one station, which is called as base station. Then it is given to somebody who is a agriculture specialist. So that agricultural specialist might not be there near to you, but you can capture those data by using sensor network. You can put all those data together in a sync node, or today cloud computing is there. Through the cloud you can send the data to the agriculture specialist who may be at London at present. So he will just check all the data of your agricultural field, and he will give you suggestion that yes, if you want to do this crop on this field, you have to add this kind of fertilizer, or you have to add this kind of things, so that it will make the soil a good one. So for agriculture, you can make, for different shopping malls, you can make a sensor network. Big stadiums are there. So we want to control every part of a stadium from one control room. That's there we are finding the application of sensor networks. So applications are many. We will be keep on seeing, but there's a very critical application for airborne wireless network that I have shown. Okay, so far I have shown you all the hardwares, or what is there inside a sensor network hardware. That is one thing I have shown, and one application I have shown. Another application I would like to show here, there is the application of ad hoc wireless network, and this is something called as a topology. So yesterday I had told you this word topology. So what is meant by topology? So this is a sensor network topology you can see here. What is a sensor network topology? So first I'll explain what is this actually, what is this slide about. So this right side you can see here, this is a sea, Samandar. Okay, so this is a sea, and in sea we know that some aeroplane has sunk at a certain point. Let's say this is the activity. We are supposed to find out exactly at which point inside the sea the aeroplane has sunk. And if you can localize exactly at which point the aeroplane has sunk, then only we can start the rescue operation. So this circle, whichever is there, I think you can see this in the right side, there is something moving part, or something is moving in the circular fashion. This is the point exactly where the aeroplane has sunk, and we want to find out the location of this point. Okay, so who is going to find it? Now you can see there very small dots are there. So these very small dots are nothing but randomly deployed sensor nodes. Okay, so we can randomly deploy the sensor nodes on the sea surface, and the nodes will be there on the sea surface, and because they are having the flagella and all those things, they are having some kind of fins, so they can swim on the seabed, and they can stay there at those positions. So those sensor nodes are also having some kind of sensing capacity. You might have heard of sonar, you might have heard of ultrasonic kind of a sensor. So these sensors, what they will do is they will send some ultrasound or something to the below of the water surface. And if the aeroplane is there already sunk, it is there below, then this ultrasound will go hit the aeroplane body and come back to this sensor nodes. So collaboratively together, all these sensor nodes A, B, C, D, E, F, they are different sensor nodes. So all the sensor nodes together, they will be able to track exactly at which point the aeroplane is there below the water surface. Once it is found that yes, exact location of the aeroplane has been detected, in that case what will happen is this A, B, C, D, E, F, so there is a certain path. Through that path, the path is being shown now. Okay, so the path will be built, and through this communication path the data about the activity will be sent to the user. So we are there at a sea surface. Sea surface might be very far off from the land, and there's aeroplane has sunk, and these sensor nodes are deployed randomly in local area, maybe about over 5 or 6 square kilometer area. All the sensor nodes are deployed. Now the sensor nodes, as soon as they're deployed on the sea surface, they will start sending ultrasonic sound or sonar to the towards the below direction, below the sea surface, and some of the sensor nodes, they find that yes, they have hit the aeroplane, or they have hit some metal kind of a thing. So then those sensor nodes, wherever they're positioned, they will talk about their location to the data sink. So this is the data sink, or this is the base station. So location of this A sensor, which is closest to the aeroplane, it will come. So this is the path through which this is called signal transmission path. Through this, the signal will be coming to the data sink. Now data sink will send, so this is still local. Data sink will now send the information to the satellite and task manager on node. So maybe we are here in the city of Mumbai or Pune, but some aeroplane has sunk maybe in the deep in Arabian Sea. So just by sitting at Mumbai or Pune, we can find out something which is happening 1,000 or 2,000 kilometer away. So this is total thing is called as a topology. So what are the components of the topology? Topology means how all these things are arranged within this area. So all these things means there are sensor nodes, there is a signal transmission path, there is a sync node. Sync node means this is a node where all sensors are going to send their data, and all this data are being sent in a wireless fashion. That's why all the sensor nodes should be having a transceiver unit with them. Transceiver unit is transmitter and receiver, so there should be a transmitting antenna, there should be a receiving antenna. Okay, so and they are sending the data to the data sink. So in this data sink, the data is being processed because data from many sensor node is coming to the data sink, and all are talking about the same activity. Now inference is drawn at the data sink. That inference is uploaded through the cloud to the user who is maybe 1,000 or 2,000 kilometers away. So all these things together, this thing is called as topology. So topology is nothing but the connection of all the sensor nodes, its data sink, its gateway, its cloud, and then user. So starting from the activity to the user, whatever things are helping to bring the data, that are creating the topology for a specific application. So this slide is also very important because this slide is actually overall application, any kind of application you can say. So here I have taken a aeroplane has sunk, that application. Somebody can give agricultural application, somebody can give airborne traffic control application, but this diagram you have to remember to design for any kind of application. I'll go for, so this was one part of today's lecture, that is hardware, then topology, then certain application of ad hoc network and wireless sensor network. Then we will come to a very important thing, and this is a very important question: what are the constraints or what are the limitations of ad hoc sensor network? So ad hoc sensor network is always in a constraint situation. I have told you so far that is there is very less bandwidth, there is lot of sensors in one position, energy is less, all those things are there because we are putting all those things, all those sensor nodes to maybe some forest or something, and we are not staying there, we are coming back. Okay, so every day not possible to go and change the battery. Okay, so what are the different types of constraint for ad hoc network? So this is also an important question. Please, if possible, jot the points down. So first thing, it is a infrastructure less system. So whenever I'm saying ad hoc means it's temporary. There is no certain base station. And as there is no base station, I told you yesterday that it is like a college without a principal. So if there is no principal, then there is no head of decision making thing. So this is a network without any head. This is a network without any kind of base station. So in that case, how to take the decision, who is going to send, who is not, how to route the data, all this thing, a smart network, it does automatically. So there are a lot of coding, there are a lot of intelligence inbuilt inside the sensor network or ad hoc network, and they can take their own decision. Okay, so infrastructure less is a constraint for the ad hoc network. It says that lack of centralized entity. Who is the centralized entity? It is called as that common access point, or is the base station. So there is no common access point or base station in case of ad hoc network. Hence, the network management has to be distributed over the network. It leads to a lots of problem. So there are different kinds of problem if there is no base station or central processing unit. Second thing, dynamically changing network topology. So I told you that the nodes are mobile. Mobile does not mean mobile phone. Mobile means mobility. Okay, the networks are continuously moving from here and there, and that's why the path between the transmitter and receiver or sender and receiver is continuously changing. Okay, under that condition, also we should be able to transmit data from the transmitter to the receiver. So unpredictability, there is a breaking of the path, and the path's dynamics changing because the node position is changing due to mobility. So dynamically changing network topology is creating frequent route change and frequent packet losses. But then also we have to transmit the data from transmitter to the receiver. So it's a highly challenging kind of a environment like this. Third thing is physical layer limitations. So actually OSI layer, there are a lot of layers in OSI kind of architecture. There are a lot of layers. So below the most below layer is called as physical layer, where all the sensors and all the devices are there. The physical layer means we can touch it, we can feel it. So physical layer, all the data is generated, all the data is sensed. Wherever sensors are there, that is the physical layer. What is the limitation in the physical layer? It says that radios means the communication thing. So radios used generally in broadcast mode with limited power and range. So what is broadcast? Broadcast means one node is transmitting and all other nodes are listening. So now whatever is happening, only I'm talking and you all are listening. So this is kind of a broadcast. It is not a duplex kind of communication which is happening now. It is unidirectional communication. Only I am telling, and I am telling to all. So there may be thousands of people who might be listening to my lecture. So that is called as a broadcast. Whatever happens in TV. Okay, so some match is being relayed and from one station, and we all are watching that. So that is kind of a broadcast. So radios are used generally in broadcast mode with limited power and range. This leads to issues like hidden and exposed node problem. So I'll not be able to explain what is hidden node and what is exposed node, but this is a very big problem that happens in case of ad hoc wireless network. And it's all happening because of this broadcast kind of thing. So one thing, if you are having pen and paper, you can write down. This thing will be matter of discussion maybe next day or next to next lecture. What is hidden node and what is exposed node? Very frequently asked question, very favorite question for all the examiners. So in ad hoc sensor network, what is hidden node and what is exposed node? Actually, these are some kind of problem, and we can solve this problem by proper protocol setting. So this is a problem that happens at the MAC layer. This is a problem that happens in case of sensor and physical layer. Last thing, limited link bandwidth. I told you that there are highly dense sensor networks, so huge numbers of sensor nodes are put together, and they all are trying to fetch data from the same bandwidth. Okay, hence there will be a bandwidth limitation. So all the networks will not be getting the bandwidth. Exactly the same thing happens when many mobile users come in the same area and they all try to access Gmail or WhatsApp or maybe some video, YouTube from the same place. Okay, because bandwidth gets shared and all the people are having very less bandwidth, and किसी का भी phone चल नहीं रहा है, किसी का भी कोई data download नहीं हो रहा. So exactly that is the problem happens in case of ad hoc network. So this is a set of limitation. Some common challenges in case of ad hoc networks. Okay. So previous was what are the limitations, what are the constraints, and now what is common challenges. So if you want to design some ad hoc network, these are the things you have to keep in mind. First thing is scalability. What is meant by scalability? Suppose if there are 4, 5, 6 sensor nodes, you can get output, because 4, 5, 6 sensor nodes means each of the node is getting. So 4, 5, 6 is a less number. Okay, so there are nodes, node hardware I have already shown you at the starting of this lecture. So such 10, 15 or maybe 6 to 10 nodes are there in one place. They all are measuring temperature of one place and sending it back to the base station. It is okay. What is meant by scalability? So instead of 5, 6, 10 nodes, you are putting 2000 nodes there within that small area. What happens? First thing, bandwidth gets shared. So previously 6 or 10 nodes were sharing the bandwidth. They were able to sense the data, they were able to transmit the data. But as soon as you are putting 2000 sensor nodes within that small area, what happens? Bandwidth is shared by all 2000 sensor nodes. None of the sensors is able to, they can all sense properly, but none of the sensor is able to send the data properly, because bandwidth is shared and everybody is getting very small bandwidth to send the data. So that is the scalability problem. Providing acceptable levels of service even with large number of nodes, that is a problem. So whenever small number of nodes are there, like if there is a class, there is 60 students, I can teach very well. But in the same class, somebody puts 200 students, I may not be able to teach very good, or there will be a lot of chaos or other things. Exactly the same thing is called as scalability. So scalability means huge number. Upscaling and downscaling. So downscaling means small number, upscaling means huge number of sensor nodes. Throughput is nothing but output. Output decreases at a rate of square of n. So more you are increasing. So if you are getting a certain kind of output from a sensor network, suppose if you double the number of nodes in that case, so square of that, double means square of 2 is 4. So as soon as you are doubling the number of nodes there, output will reduce by 1/4 times. If you are making the number of nodes as 3 times, output will reduce by 9 times. So that is what it is said, that throughput decreases at rate of square root of n. So number of nodes are 5, suddenly you have doubled the number of nodes. What you will find is the energy in the output, density of the energy in the output has become 1/4. That is a very big problem. So this is scalability problem. Quality of service. This is the whole third chapter is dedicated on quality of service. Whatever job the sensor network is doing, that has to be done very properly. So if one node is sending a data packet from one place to the other, it has to be ensured that the data reaches within a proper time and the data is not tampered and the data is intact. Okay, suppose your mother has sent a dabba of laddu through your friend to you. You are staying at hostel, but when the dabba reaches to you, it is already 20 days late. Dabba, the all laddu has become rotten. That is the first thing. It has reached, instead of 2 days, it has reached after 20 days, and you find that mother has sent you 10 laddu, but you have received 2. So same thing happens in case of data also. Suppose from here to some other place, data has to be transmitted. You had sent 10 data, but number of data reaching at the receiver is 3. And at the same time, you are finding you had sent some data, and over the channel, the data has been modified and data has been tampered and security has been breached. That is not required. And last thing, you send the data and you expected it to reach within two seconds, but you are finding the data has reached after 2 hours. So what is meant by quality of service? 3 things, very important thing, and if possible, write down that in quality of service, we ensure 3 things. That is, data transmitted is received within proper time. So time is very important thing in case of quality of service. Second thing, whatever number of data is transmitted, the same number of data is received at the receiver side. So number of packets, number of data, amount of data. So first thing is it has to reach within time. Second thing is it has to reach without any kind of dropping of packet. So number of packet transmitted should be equal to number of packet received. And third thing, whatever is the quality of packet, exactly the data you had sent, the same exact kind of data should be received. So type of data, time of data, and quantity of data. These 3 things, if we can ensure, then we are saying that we are giving a quality of service to our user. So it is saying offering guarantee for bandwidth, delays time, jitter, packet loss probability, bandwidth, unpredictable changes in RF channel character. All those things we have to see that all those negative things does not happen. High bandwidth, less delay, less jitter, no packet loss, proper bandwidth, and no changes in the data packet. These are the quality of service that we have to ensure. Energy efficiency, all the nodes should be up at all the time, all the nodes should be able to transmit data all the time. If we are finding that yes, the energy in the data, in energy in the node is less, either replenish the battery or reroute the path so that nodes with higher energy, they get to transmit the data. Okay, so nodes need to cooperate with other nodes for relaying information. So we have to ensure that all the nodes are having enough energy to transmit the data. And obviously, security is the biggest problem because this is a wireless environment, and wired environment are not bridged by security. But wireless environment, anybody can tap the signal and anybody can play with the signal, and they can bridge the security, and the security might be a problem for any kind of wireless system. So these are the four challenges in ad hoc network. We have to put huge number of sensor nodes, and then also we should be able to give quality of service, and all the nodes should be energy efficient, and security should be kept intact. I think this is the last slide. A big constraint for ad hoc sensor network is device heterogeneity. What is meant by heterogeneity? A ad hoc sensor node, not necessary that it will be containing only the mobile phones. So yesterday I told you there are two types of network. One is homogeneous, one is heterogeneous. If all mobile phones are creating one network, in that case we can call this is a homogeneous network. But if mobile phones, laptop, palm top, tablet, all those things, notebooks together, so there are many different kinds of hardware within a network, and they all are accessing the network. In that case, it is called heterogeneous. So this is called device heterogeneity. Compatibility of all device for heterogeneous devices within a network is a very big problem. So this is called a big constraint for ad hoc network. First thing is device heterogeneity. Second, differences in capacity and device power. So some laptop might be using very huge power, some node might be using very small power, require very small power. Sometime battery and lifetime for all the nodes and all the devices within the network is not same. So sometimes some node will die first, some node are there still working, so the routing path and other thing will get disrupted. So differences in capacity and device power is a problem in case of heterogeneity. Heterogeneity means differences. Okay, all humans are different, so their capability is different, their energy level is different. So such different energy level people put together, they disrupt the job. Third thing is cooperation is forwarding packets. So differential dissipation of limited energy of device. So the same thing I told you, that if energy level of some uh, node is very less, it do some 3-4 transmission and it dies. And after that, that node was a part of a path. That node was a part of a data path from transmitter to receiver. But nobody knows that that node died because it was having very less energy, and data is not being forwarded through that path. So that route is gone, but we don't know. Okay. So in that case, this because of energy variation in deficiency, cooperation in forwarding packets will not happen. This will hamper the quality of service. So this happens because of device heterogeneity. The last thing, it says that problem get further complicated with so much of heterogeneity. Sometimes it is possible that within one ad hoc network we are using Zigbee and maybe Bluetooth and IR together. So different kinds of communication paradigms are being used within one ad hoc sensor network. That is also possible. So more is the heterogeneity, more will be the complex to interchange data from one device to another device, and that will create more confusion among these devices. So whenever we are designing some kind of ad hoc network, we have to ensure that even with there is heterogeneity, we are able to maintain the flow of the data from the transmitter to the receiver side. So problem gets further complicated with so much of heterogeneity. Okay, so next lecture onwards, we will start with, please write down the page number. Tonight I will follow, I'll send you the PDF of that book, because we are having a lot of copies of this book in our college, but as you are not able to access our library, so this whatever I'm going to discuss from next lecture onwards, it will be found between page number 206 to 227 of the PDF. So this page number you have to write down, and whatever I've explained till now, you have to do it from my notes only or my videos only. or you can check any book you'll find. But this much whatever is done is enough. But next time onwards, next lecture onwards, whatever I teach, that will be found in the book of Manoj from page number 206 to 227. Okay. So I'm logging off today, and this lecture PDF, so this 810 PDF, whatever is there, this I'll post in the group, and whatever is the lecture video, I'll upload into YouTube, and I will send you the link. So whatever was uploaded yesterday, please listen to that, and today's lecture also, you please listen. Okay. So thank you. See you then next week.